5, 4, 3, 2, 1. Hello, I'm Commander Chris Kreitline, U.S. Navy retired, sitting aboard my Cape Dory 30 cutter in Pensacola, Florida. And in this video, we are going to talk about the marine sextant, what it is, and how it's used. Now, sextants come in all different styles. You have the very cheapest sextants, plastic, and then you have metal sextants that then become quite expensive. This is an Astra 3B, and in the current catalog, it's about $665. A plastic sextant for a student, of course, is all you need. But once you really get into the art of celestial navigation, you may want to get yourself a metal sextant. And this is a good one to get. So let's talk about the sextant and what it's used for. And then finally, how you use it. The first thing on this sextant is the handle. This is where you hold the sextant, and in this one, and in many of them, you have a place to put some batteries with a light. The purpose of the light is to eliminate this reading area here so that you can read the degrees at night, twilight, when you're shooting the stars or the moon or the planets. Instead of having to hold a flashlight or putting a headlamp on your head to read it, you can just push the button and read it. So that's a handy little thing to have on a sextant. Then you have two vertical pins right here, and that supports the sextant when you lay it down. Always take good care of your sextant. It'll last your entire lifetime if you take care never to drop it. If you drop it, of course, you may bend it, and that would affect its accuracy. So you want to take good care of your sextant. Always store it in its box when you're not using it. Okay, so let's continue with the sextant. The first thing we'll talk about here is the sextant arc. That's this curved piece of metal here upon which are inscribed the degrees. That is called the sextant arc, and that is where you will measure the angle that you're shooting with the sextant. Now, a sextant, let me interrupt here for a second and tell you that a sextant is really nothing more than a very fancy protractor. You might have, I suspect that you used a protractor in high school to measure angles. That's exactly what a sextant does. A sextant measures angles. Of course, it's a fancy and expensive protractor, but really that's about all it is a protractor. Now, sextants, of course, were developed probably in around the 1600s time frame, early 1700s. Before that, they used the forestaff and the backstaff. Those were tools used to measure the angle from the horizon up to the North Star, or the angle of the horizon up to the sun. Then they developed a rudimentary sextant called a quadrant, and that's what Columbus carried with him on his voyages. Unfortunately, if you read about Columbus, you'll learn that he didn't know how to use it. The readings that he took were way off. But anyway, that was a quadrant. And now we have the sextant, named because it measures 1/6 of 360 degrees, hence the name sextant. Now, let's continue. We talked about the arc. The next obvious element on the sextant is called the swing arm. That's this thing that you move here as you measure the angle that you're taking. Has a squeeze knob here. Now, sextants are different. There may be other little mechanisms here to move this swing arm, but on this one, you pinch these things together and move this swing arm. So what you would do when sighting with the sextant, we'll talk about in a few minutes, you move the swing arm and bring the star to the horizon in a rough fashion, releasing it, making sure it's locked, and then you move on to adjust the micrometer here. Now, the swing arm will determine the the degrees of the angle. Of course, you're shooting the angle from the horizon up to the star. This will measure the degrees. Then this micrometer measures the minutes and tenths of a minute. You may remember from high school that angles are measured in degrees, and then in each degree are 60 minutes, and in each minute are 60 seconds. So you might think a sextant would measure degrees, minutes, and seconds, but it doesn't. It measures minutes and tenths of a minute on the micrometer. So that's what the micrometer does. You set it, you get the star at a good position, and then you adjust it with the micrometer to put it right on the horizon. All right, so that's what the function of the swing arm and the micrometer. Let's move on to this eyepiece. Now, eyepieces can be just a hollow tube with no magnification, no lenses, just a hollow tube, or a little telescope. This one is a little telescope. I think it's a 5-power telescope. And that is good, to make things very well defined for you, the reflection from the mirrors. However, a telescope can also cause you trouble in that a star is hard to see at night, at dusk, because it's not really dark yet, it's still a little light. So sometimes it's hard to get the star, and then when you have it magnified, it's even harder to get it in the mirrors like you should and put it exactly on the horizon. So that you'll find out as you use a sextant that you may or may not prefer to use the telescope. Generally for stars, I just use a hollow tube. For the sun, yes, you can use a telescope, and it really shows the sun very clearly, and you can put the bottom edge on the horizon or the top limb of the sun on the horizon. But for stars, I generally find that a telescope makes it more difficult to find the star, because you're looking and trying to get the star here in the mirror, and it can be a real hassle trying to do that with the telescope. Okay, but that's up to you, however you prefer. But that's what the purpose of it is. Then we have here, the next important elements are the mirrors. We have the horizon mirror here, and this is the one, it's generally split in two. One is clear, the other one has a mirror. And then you have the index mirror at the top. The index mirror is hooked to the swing arm. So as you swing it, you'll pick up the star in this index mirror. It's reflected down to the horizon mirror, and that is reflected into the eyepiece. And that's what you'll see. You'll see this reflection. Okay, so those are the two mirrors, and these are the mirrors that you adjust to increase the accuracy of the sextant. One thing good about a metal sextant, once you set the mirrors, they generally stay that way until you drop it or mishandle the sextant. A plastic sextant, you may have to adjust the mirrors a little bit each time before you use the sextant. However, to adjust these mirrors takes a special tool. So fortunately, you don't have to adjust them. To adjust the mirrors on a plastic sextant, you just turn these little screw knobs. So it's quite simple. So it's really not that much of a hassle to adjust the plastic sextant's mirrors before you use it. So don't let that stop you. You can do it very quickly. It's pretty easy, but you will probably have to do that before you use the sextant. Okay, so we have the index and the horizon mirror. And then to protect your eyes from the sun, there are a series of filters that you apply of different colors. And I can't tell you which to use. That's something personal preference you will have to determine. Of course, it depends on the day, how bright the sun is. Of course, they're used for the sun. You don't want to use any filters for stars, generally speaking, or the moon. I don't know, maybe there might be an instance where you would want to, but that would be your own personal preference. But these filters are really to protect your eyes from the sun, particularly if you have a telescope in there. You could burn your retina if you looked at the sun without the filters. So what I recommend to people is to put the filters there when you start your observations of the sun. Then remove them until it looks good to you. Don't start out without filters and add them. No, that would be a mistake. You want to start out with all the filters, then remove them one at a time until it's comfortable for you, so you can see both the horizon and the sun. Okay, now remember, these down here really are to adjust the reflection of the horizon. And sometimes out on the water when it's really, really bright, you'll definitely need this to cut down that reflection off the water so that you get a good view of the sun. Okay, so those are the parts of the sextant. And like I said, always keep it in its box when you're not using it and protect it. Now, how do you use a sextant? Well, let's go over that. Of course, I have that in one of my other videos, shooting the sun at noon, but I want to go over here again with you. Well, we have the sun here, a beautiful day. So what I can do is put up my filters and then remove them, as I feel comfortable. But how will I know what to remove? Well, first of all, I've got to pick up the sun in the sextant. So, it becomes a process of adjusting the filters until you can see the sun and the horizon at the same time. So I'll put some filters up here. I'll look through the mirror. Okay, now this looks very good for the horizon. Then I'll get this. I'll look for the sun by moving the swing arm back and forth. You want to line your sextant up with the sun's reflection on the water. It's not that tough seeing the sun. You won't find it very difficult at all. And you start looking through here, removing filters as you need to until you see the sun. And it might surprise you. It may be just a little tiny round orange ball if you're not using a telescope on your sextant. If you're using the telescope, of course, it'll be larger. But you'll find the sun and you'll bring it down slowly to the horizon, near the horizon. Make sure you lock in the swing arm, and then you begin to adjust the micrometer. And what you want to do is bring the sun's lower limb, the bottom edge of the sun, down to the horizon. If the bottom edge of the sun is obscured for some reason, a cloud, for example, then you can use the upper limb of the sun. Of course, you'll have to note that when you do it, because that makes a difference in your calculations later. That's in another lecture. And we won't talk about that today, but I'm just telling you now, you can either use the lower limb of the sun or the upper limb of the sun. So once again, you find the sun, you've brought it down, now you're adjusting the micrometer, you bring it down so the lower limb of the sun is just kissing the horizon. Then you want to swing the sextant just a little bit right to left, left to right, and adjust it to make sure that the bottom edge of that sun is just touching the horizon. When you got it where you like it, you say mark. And that is where you then look at your chronometer and note the time. Write that down first, the time. If you have an assistant with you, your first mate or whatever, when you say mark, they should look at their chronometer and note the time. Then at your leisure, you can look at the arc and read the minutes, and then look at the micrometer. And you look at the arc and read the degrees. I keep making that mistake. You look at the degrees, then you look at the micrometer and read the minutes and tenths of a minute off of the micrometer. Okay, so that's really the process for shooting the sun. Well, then let's talk for just a little bit about how to shoot the stars in the evening, which are more difficult. A star, of course, is not nearly as bright as the sun. And you're generally doing this at what we call civil twilight, when there's still a little light in the sky, and that compounds the difficulty. But anyway, you have an idea through other processes of the star you want to shoot. And of course, it could be a planet or the moon. That's up to you, whatever you're shooting. But for our discussion here, I'm using a star. Let's say we're going to shoot Antares, a rather bright star in the constellation Scorpion. You will find Antares in the sky. It'll be brighter, so it'll come up first as the sun sinks below the horizon. You keep looking in that direction. And there are some other things I discuss in my book on how you can find these stars. But let's just assume that you know Antares and where it's at, and you're looking for it. As it gets darker, then you'll see Antares pop up in the sky. And you know that's the one you want to shoot now. Well, if you just take your sextant and try to find it, it's hard as heck to just find that star and get it down to the horizon. So I'm going to teach you a little trick. What you do is you turn the sextant upside down and you look through the telescope and look straight at Antares. Normally you're looking straight at the horizon and you're bringing the reflection of the heavenly body to the horizon. Well, now what we're going to do is look straight at Antares with the telescope or the hollow tube. Once again, I recommend the hollow tube. That's what I use because it's, you know, whenever you use a telescope, generally it cuts down on the brightness of what you're looking at. It certainly can, because it's going through different lenses. Of course, some of them might magnify that, but still I find it better to use the hollow tube. But that's up to you. Experiment and determine for yourself what you like better. But you look through the eyepiece, you find Antares, and then you move the swing arm with your other hand and bring the horizon up to the star. It doesn't have to be right on, but you want to get it close. You bring it as close as you can with the swing arm, then you turn the sextant back around, and at that point then, you will see the star near the horizon. It might be a little above, it might be a little below, but at least you've got them together, and that, you know, is 50% of the problem, getting them together. Then you take your micrometer, make sure it's clicked in, you take your micrometer and line it up the way you like it. You get the star right on the horizon, and you want to be doing this quickly. Why? Because you got 2 other stars to shoot. So don't be dilly-dallying around with it. Get it on the horizon as fast as you can. Swing it to make it sure it's kissing the horizon, and then mark. Look at your chronometer and note the time. I use a headlamp up here. So I'll go mark. I set down the sextant, turn on my headlamp, and check the chronometer. I may even, you know, subtract a couple seconds from it. So, because I've wasted, you know, a couple seconds sitting down my sextant. Okay, so I might subtract a couple seconds from my reading to make it more accurate. I note the time, I write it on my form, and then I can either use the button on this sextant or I use my headlamp to read the degrees. There, I got it right that time. The degrees, the minutes, and tenths of minutes off the micrometer. So there, that's really the process. I've described to you the sextant, what it's used for, a little bit about its history, what the different parts on the sextant are used for, you know, how you use them, and we've talked about how to shoot the sun then, and the process for shooting the stars. So I hope you found that beneficial. I hope you understand then, or now, better a little bit about the sextant and how it's used. Always treat it carefully. Always treat it with respect. Who knows, you may need it to get back to land someday. So treat it with respect. At this time, I'd like to put in a plug for my other videos. I do have videos on YouTube for you to watch where I step through the whole process of shooting the sun at local apparent noon. The first of those series of 5 videos, I also talk about the sextant. So some things that maybe I've forgotten here, you might pick up on that first video of shooting the sun at local apparent noon. I also have a video on there about how to plot. So you might want to watch that also. And I hope you enjoy it. Leave me any comments that you have. My email is on there. I also talk about the book I've written on celestial navigation. It's called Simple Celestial Navigation by the Heavens Made Easy. I hope you enjoy celestial navigation. Once again, if you got any questions, send me an email. My website is globizon.com. globizon.com. My email is there at the website. Go there. See what I've got at the website. I've got about a 5-page sheet on tips for using a sextant that I hope you find helpful. Thank you very much for your attention. Here I am in Pensacola. Today is the 6th of December. I'm sitting here in shorts and t-shirt. Life in paradise is great. Have a good day.